Morning, ladies. Today we were moving on to a new topic which is called indices or exponents. Some call it indices and some call it exponents. It's exactly the same thing. Now, we want to talk about the rules of exponents, solve equations that are in exponent form. But before we go there, numbers that are in exponent form, they are written in this form. You read this as A 2 you read this as A to the power of n. You read this A to the power of n. So that power, that n, is the one that shows that the number is in indices form or is in exponent form. But what is the meaning? Before we go to the meaning, this one that is down, it is called the base. And this one, it is called the power. It is called the power or the exponent. It is called the power or the exponent. In A, it is called the what? It is called the base. But what is the meaning of A to the power of n? This time I'm going to give numbers. If you are given something like 2, e.g., 2 to the power of 3, 2 to the power of 3. What does that mean when they are saying 2 to the power of 3? When they are saying 2 to the power of 3, it means multiply 2 3 times. That's what it says. I need to multiply 2 by itself. But how many times? 3 times. So 2 to the power of 3, it means 2 times 2 times 2. We are saying multiply 2 3 times. And most people have got a mistake of saying 2 to the power of 3 is equals to 2 times 3. This is a common mistake and it is very wrong. When we are saying 2 to the power of 3, it means we need to multiply 2 3 times, multiply 2 3 times. So it means 2 times 2 times 2, not 2 times 3. This is a common mistake and it's very wrong. So we are saying 2 to the power of 3. It is equals to 2 times 2 times 2. 2 times 2 times 2. That is the meaning of what? Of 2 to the power of 3. Then now, when we are dealing with exponents, normally we use the laws. But before we go to laws, given that let's do something like this. 2 to the power of 3 times 2 to the power of 2. We want to see where does the law come from. We are saying 2 to the power of 3. It means multiply 2 3 times, which is going to be 2 times 2 times 2. And we have got a multiplication here, multiply by 2 to the power of 2. We are multiplying 2 times, multiply by 2 times 2. But whether there is a big multiplication or a small multiplication, we are ending up with how many twos? With 5 twos. We end up with 5 twos. 1, 2, 3, 4, 5. So this is the same as 2 to the power of 5. That's where the rule. So now to talk of the laws, law number 1. Law 1, which say, must I use X or X? Let's use A, which say A to the power of M multiplied by A to the power of N, is equals to A to the power of M plus N. This is the law that we are going to talk about today. This is the law that we are going to talk about today. As you can see from the example on top, 2 to the power of 3 times 2 to the power of 3, you end up getting 2 to the power of 5, whereas it was exactly the same as just saying 3 plus 2. 3 plus 2, you get what? You get 5. So the rule here is When the base is the same, it only applies when the base is what? Is the same. When the base is the same, what do you do to the, when the base is the same and you are multiplying, you plus the powers. Here we are saying a to the power of m multiplied by a to the power of n is equals to a to the power of m plus n. This rule only applies only if the base are the same. If the base are not the same, the rule doesn't apply. It only applies when the base are the what? Are the same. Let's do examples. E.g., number 1, simply it will say simplify. Simplify. Number 1, 3 to the power of 2 multiplied by 3 to the power of 4. 3 to the power of 2 multiplied by 3 to the power of 4. What do? You check if the base are the same. What do? You check if the base are the same. Yes, in this case, the base are the same. So if the base are the same, I keep the base. And what do? To the powers? You add the powers, because that's the rule. There is the rule. It says if you are multiplying and the base are the same, if you are multiplying and the base are the same, what do? You keep the base and you add the what? The exponents or the powers. That's what we did here, which is equals to 3 to the power of 6. And the question, it says simplifying. When you are simplifying, it means you have to leave your answer in exponent form. We don't want the numerical value, the answer, the numerical value of that. We are not going to end up saying 3 times 3 times 3 times 3 and get the answer. No, you just want to leave the answer in exponent form. Example number 2. 5 to the power of 2 multiplied by 5. 5 to the power of 2 multiplied by 5. But when we're doing highest common factor and lowest common multiple, I said whenever there is no power, it means there is power of what? Power of 1. It means here I can put 1 there. Because if there's no power, just know that there is an imaginary 1. You are allowed to put that 1, which is equals to, the base are the same. So it means you can say 5 to the power of 2 plus 1, which is equals to 5 to the power of 3, because the base are what? Are the same. In this case, the base are the same. So if the base are the same, what do? You add the what? You add the powers, but you keep the 5. So it goes to 5 to the power of 2 plus 1. Then number 3, example number 3. 8x, the screen is slow to respond. I'm waiting for the screen. My board is not showing. Okay, let me pause, then I'll come back. Okay, then example number 3. 8x to the power of 5 multiplied by 4x to the power of 3. Let me write the same x's. 8x to the power of 5 multiplied by 4x to the power of 3. In this case, you are going to do the numbers on their own, the x's on their own. But remember, we are saying 8 multiplied by 4. In this case, you are not going, and most people have a mistake of saying 8 plus 4. When you are multiplying the numbers, you don't add the numbers. We say the rule, it only add the exponent. So it means 8 times 4. It stays as it is. The multiplication is, we know it, so it's going to be 8 times 4, which is going to be 32. So it's 32 x to the power of 5 plus 3. It's only the exponent that we are going to what? To add. The multiplication stays as it is. It's only what? The exponents that we are going to what? To add, which is equals to 32 x to the power of 8, which is equals to 32 x to the power of what? The power of 8. Example number 4. Example number 4. 3m squared n times minus 2m, my space here, let me start it over. Number 4, 3m squared n times minus 2m n to the power of 3. We are multiplying 2m squared n times minus 2m n to the power of 3. In this one, you do the numbers on their own, you do the m on their own, and you do the n on their own. But we know that for n, if there is no power, it means there is the power of 1. So I can put that 1. It means there is the power of 1. And for m, it means also there is a power of what? There is a power of 1. I can put that 1 because where there is no exponent, it means the power of 1. So in this one, I need to look for the sign. Remember, we did multiplication of integer. I've got a positive number multiplied by a negative number. I've got a positive number multiplied by a negative number. So my answer is going to be a what? A negative. My answer will be a negative. So my answer is going to be minus. And what is 6? What is 3 times 2? 3 times 2 is 6. Then I'm going to do the m on their own, which is going to be m to the power of 2 plus 1, which is going to be m to the power of 2 plus 1. And n to the power of 1 plus 3. Because remember, when you are multiplying exponents, what do you do to the powers? You add the powers. But when you are doing this, you do the numbers on their own. You do the letters that are the same on their own. So you do the m on their own and you do the n on their own. But the multiplication of numbers, it doesn't change. That's why we said 3 times 2. We are not going to say 3 plus minus 2. Multiplication of numbers, it stays as it is, which is equals to minus 6m to the power of 3n to the power of 4. That is what? That is your answer. So that is our examples for today. And for homework, I will send you it's from the book. I will send you the homework after this. Thank you for watching and enjoy. I hope you enjoyed your Christmas. It's still, we are waiting for the new year. Always, there it is. Thank you for watching and enjoy and keep enjoying your holidays with your family. Thank you.